Okay, so today we are going to be covering factoring polynomials in perfect squares, or what we call a difference of two squares. And so this is really a good way for us to recognize patterns and then to make things a little bit easier for ourselves. So what this looks like is that we have two numbers like this x squared minus 49 here. We can factor this polynomial using this method. Here's the reason why. A difference of squares refers to a subtraction method here. And so because I have this subtraction symbol here, that's the first thing I can look for. Two values and a little minus or subtraction sign is going to be my key to knowing that I can solve it this way. The next thing I'm going to check is that both of the values in my problem are perfect squares. Now let's review what a perfect square is. A perfect square is any number times itself. Is the result of, I should say, any number times itself. Okay, so an example of this would be x times x is equal to x squared. The x squared is a perfect square. And I wrote that out wrong, so x, I'm gonna put that 2 up where it's supposed to be. And then these guys here are what we call the square roots of x squared. Now a number value might be 81, which is 9 times 9. So those are some perfect squares. Now a tip for you guys, memorize the perfect squares up to about 15. Okay, that's kind of your key and what you're going to be working with most of the time here. So that means 1 times 1 is 2, or sorry, 1 times 1 is 1, and 2 times 2 is 4, and 3 times 3 is 9, and so on. And so that's kind of just your tip. It'll make this unit a lot easier, but if you remember anything from our GCF unit, this tip doesn't necessarily have to matter because you can find out if a number is a perfect square or a perfect cube using the skills we've learned before. Okay, the next thing that we're going to do is, now that we can determine that yes, x squared is a perfect square and 49 is 7 times 7, so you have to know that in order to be able to do it, we can set this up. So just like in our previous factoring videos, we want to create 2 brackets just like this, and you're going to split up the square roots of both of them and put them in each individual bracket. So for example, we're going to split up the x first. And so the x, 1x here and 1x here, because when they were to multiply to each other, you're going to get x squared from that. Now, because of the subtraction, I'm going to put a plus in one bracket and a minus in the other bracket. This is really important. You don't want 2 negatives and you don't want 2 positives, because then it won't work out, and I'll show you why in a second. So then I'm going to have my 49 split up. I'm going to put a 7 in each bracket. Now, let me FOIL this out so that I can show you that this is actually working here. So x times x is x squared. X times negative 7 is negative 7x. Then I've got plus 7x. And then I have minus 49. Now, we know that we would combine like terms, and negative 7x plus 7x is going to be 0. So I am left with x squared minus 49. If this was a positive value, okay, so we had x plus 7 and x plus 7, you would have gotten something that looks like this, and instead of having x squared minus 49, you would have an x squared plus 14x plus 49. And so that's kind of the difference there that we need to be aware of. Okay, let's try another one here. So the same thing, so let's go through these written out steps that I've done for you. Find the square roots of each value. Okay, well, the square roots of each value, so n squared, well, that's going to be n, and 25 is going to be 5. Okay, split the variable between the 2 brackets. Okay, so n and n. Add a plus in one bracket and a minus to the other. Plus, minus. Split the number value into the two brackets by writing its square root. Okay, so I'm going to put a 5 and a 5. Look at that. 4 steps and you can factor these perfect square questions. Super easy, super simple, not overly complex, which makes it something that anyone can do as long as you understand what our end goal is when we factor a polynomial expression. Okay, let's do this one. 36 squared minus 49. Okay, this one gets a little bit more complicated. Here, I need to find the square roots of 36, a squared, and 49. Well, we've already done 49. I know that that one's 7. And I know that a squared is going to be a. And then 36. If you know your perfect squares, you know that 36 is 6 times 6. And so you can put that there. Once I've done this, I found the square roots of each of them, I'm going to set up my two brackets just like I've done before. Now, 36a squared is being multiplied together, so they need to stay next to each other, just like we would have in a regular polynomial factoring expression. So I'm going to put the 6 and the a in each bracket right next to each other. Then I'm going to put my positive and my minus sign and put my 7s next to each other, and that is now the correct answer. So again, I will factor that one out for you. 6a times 6a is 36a squared minus 42a plus 42a, and then minus 49. Again, those get simplified, and I am left with 36a squared minus 49. It does not work if there is an addition sign here. This cannot be factored, except for taking out a GCF. Okay, and last example here is one where we have something in a bracket. Now, if you remember from previous units, what we did with something like this is we rewrote it out as x plus 5 multiplied by x plus 5. And so you notice this is something times itself, so it can work for these types of problems. So I'm going to set up my two brackets, and I'm going to write x plus 5 in each of the first ones here. And then I am going to write my minus y in each of them. And that is the factor for this one. Okay? If you have any questions or want me to do a video on a specific subject, please let me know. Otherwise, I will see you next time.